Dear students, welcome back to our second class of Introductory Agrometeorology and Climate Change. In the first chapter, this is the second class. Today we discuss the physical structure of the atmosphere and try to understand what is weather and climate. In the first class, I told a small story on a donkey, father and son. The moral was, please all and you will please none. That was the moral of the story I told in the first class. Of course, today also I am interested to say a small story. Many of you know it, but because of the importance of that particular story, I am maybe reminding many of you. Okay, anyway, this story is on crow and the pitcher, 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 crow and pitcher. Now, it's a very small, interesting story, but the morality or morale is very good. A crow, perishing with thirst, saw a pitcher. Hoping to find water, it flew to it with delight. When he reached it, he discovered to his grief that so little water that he could not possibly get at it. He tried everything he could think of to reach the water, but all his efforts were in vain. At last, he collected as many stones as he could, carry, dropping and dropping. Okay? Stones, one stone after the other, into the pitcher. One by one, with his beak, until he brought the water within his reach and thus saved his life. What is the moral of the story? Necessity is the mother of invention. Necessity is the mother of invention. So, you should become great scientists. You should become wonderful agricultural scientists. Of course, another moral of the story could be, little by little does the trick. Little by little does the trick. Okay. So, you also try to get yourself established in the environment, new environment from your intermediate. You have come to the university level. So, little by little, slowly, okay? Yes, necessity is the mother of invention. What I told in the last couple of minutes, the crow and the pitcher story. Now, so let's go into our class. Today, as I said, we are discussing the physical structure of the atmosphere. In the first class, we tried to understand what is atmosphere, what are the uses of the atmosphere for agriculture, the composition of the atmosphere. Now, as far as the physical structure of the atmosphere is concerned, on the basis of vertical temperature variation, the atmosphere is divided into different spheres or layers. Now, 5 different vertical layers are there as far as physical structure of the atmosphere is concerned. The first layer is troposphere, Troposphere. So, what is troposphere? The word troposphere means to understand very easily, troposphere is one word, however, tropo means mixing or turbulence and sphere means region. The average height of this lowermost layer of the atmosphere is about 14 kilometers above the mean sea level. However, at the equator, its height is slightly more, approximately 16 kilometers, and 7 to 8 kilometers at the poles. That means the height of the troposphere goes on decreasing as one goes from the equator to the poles. Under normal conditions, the height of the troposphere changes from place to place and season to season as well. Various types of clouds, thunderstorms, cyclones and anticyclones occur in the troposphere because of the concentration of almost all the water vapor and aerosols. In the first class I told aerosols, okay? Water vapor and aerosols are present in the troposphere. So, this layer, because of various types of clouds, because of the presence of various types of clouds, thunderstorms, cyclones and anticyclones, this layer is called as seat of weather phenomena. Okay. Now, the wind velocities increase with height and attain the maximum at the top of this layer. Another striking feature of the troposphere is that there is a decrease of temperature with increasing elevation at a mean lapse rate of about 6.5 degrees centigrade per kilometer. That means when you go out of this classroom and stand in our playground, look at the sky. If the ground temperature where you are standing at the ground, the temperature of air is say 26.5 degrees centigrade, just 1 kilometer above your head it is only 20 kilometers. That means in the troposphere where you are standing, the striking feature is that there is a decrease of temperature with increasing elevation at a mean lapse rate of about 6.5 degrees centigrade per kilometer. Of course, most of the radiation received from the sun is absorbed by the earth's surface. So, the troposphere is heated from below. In this layer, about 75% of the total gases and most of the moisture and dust particles are also present. At the top of the troposphere, there is a very shallow layer separating the troposphere from the next layer, that is the stratosphere. It is called as a tropopause. Of course, this tropopause layer is very thin and its height changes according to the latitudes, and it is a transitional zone and distinctly characterized by no major movement of air, no major movement of air in tropopause. This is with reference to troposphere. Just in a nutshell, the average height of the troposphere is 14 kilometers. It is also known as seat of weather phenomena because of the presence of various types of clouds, thunderstorms, cyclones and anticyclones. Now, so let us go to stratosphere. This layer exists above the tropopause. As I said, the average height of the troposphere is 14 kilometers. Approximately 5 kilometers height is the tropopause, of course. Now, the stratosphere starts approximately, 20 kilometers. That means approximately starts from 20 kilometers from the surface of the earth. It extends up to altitudes of about 50 or 55, 50 to 55 otherwise. This layer is called as a seat of photochemical reactions. Troposphere is known as seat of weather phenomena. Stratosphere is known as seat of photochemical reactions. This bit may come in your midterm or theory final exam. Of course, maybe in the form of fill in the blanks or match the following or one line answer, whatever it may be. So, As far as stratosphere is concerned, in any particular locality, the temperature remains practically constant at around 20 kilometers, and it is characterized as isothermal because air is thin, clear, cold and dry up to that level, up to 20 kilometers, just starting of the stratosphere. Now, from there the stratosphere starts. The temperature of stratosphere increases, not decreases like troposphere. It increases with height and also depends on troposphere because the troposphere is higher at the equator than at the poles. Now, so in the upper parts of the stratosphere, the temperatures are almost as high as those near the Earth's surface. This is due to the effect of ultraviolet radiation from the sun, which is absorbed by ozone. So, here in the stratosphere, less convection takes place because it is warm at the top and cold at the bottom. There is also persistence of circulation patterns and high wind speeds. The upper boundary layer of the stratosphere is called stratopause, like tropopause. Troposphere is separated from stratosphere by tropopause. Similarly, the top portion of the stratosphere is known as stratopause. Now, just the major differences between troposphere and the stratosphere are, as far as the temperature is concerned, the mean lapse rate of 6.5 degrees centigrade per kilometer occurs in the troposphere, that is a decrease of 6.5 degrees centigrade per kilometer. Here in the stratosphere, there is an increase of temperature as the height or elevation increases. Now, let us go to the third layer of the atmosphere. It is known as Mesosphere. Mesosphere, the third layer. The first layer is troposphere, also known as the seat of weather phenomena. The second layer is stratosphere, also known as seat of photochemical reactions. Now, the third layer is mesosphere. There is a maximum concentration of ozone between 30 and 60 kilometers above the surface of the earth. This layer is known as ozonosphere. Why we are talking ozonosphere in the mesosphere is, the troposphere average height is 14 kilometers, approximately up to 20 kilometers there is a tropopause. From 20 kilometers to approximately 50 or 50 kilometers, 55 kilometers is the stratosphere. The mesosphere starts from there. From where approximately 50 kilometers it starts. According to climatologists, the layer between 50 and 80 kilometers is called mesosphere. So, there is a maximum concentration of ozone between 30 and 60. That means a part of stratosphere and the initial part of the mesosphere, there is a layer called as ozonosphere. A property of this ozone is that it absorbs ultraviolet rays. Had there been no layer of ozone, the atmosphere, the ultraviolet rays would have reached the surface of the earth and no life on it. The temperature of the ozonosphere is high. As far as the mesosphere is concerned, the temperature goes on decreasing as the height increases, like troposphere in mesosphere as well. Okay, so this is with reference to Mesosphere. Of course, because of the preponderance of chemical processes, the Mesosphere is also known as Chemosphere. Troposphere is known as because of the presence of various types of clouds, thunderstorms, cyclones and anticyclones, it is known as seat of weather phenomena. The stratosphere is known as seat of photochemical reactions. The mesosphere is known as the chemosphere also. The fourth layer is ionosphere. The ionosphere lies beyond the ozonosphere at a height of about 80 kilometers above the surface of the earth, and it extends up to 400 kilometers. That means troposphere approximately 14 kilometers, up to 20 tropopause, 20 to 50 or 55 stratosphere, 55 to 60 stratopause. But the mesosphere starts from 50, extends up to 80 kilometers. Both in the stratosphere and mesosphere there is a ozonosphere between 30 and 60 kilometers. As far as ionosphere is concerned, it starts from about 80 kilometers because the mesosphere ends at 80 kilometers from the surface of the earth. The ionosphere lies up to 400 kilometers. The atmosphere in the ionosphere is partly ionized. Enriched ion zones exist in the ionosphere, that's why it's known as ionosphere. So this layer has some distinct ionized layers. Ionosphere has distinct ionized layers. Above the ozonosphere, that is 60 kilometers onwards, the temperature falls again. Of course, according to some climatologists, the layer between 80 and 140 kilometers is known as thermosphere. Thermosphere. The ionosphere reflects radio waves because of one or multiple reflections of short wave radio beams from the ionized shells. So, long distance radio communication is possible due to ionosphere. Now, let us go to our fifth layer of the atmosphere. The fifth layer of the atmosphere is known as exosphere. Exosphere, the outermost layer of the Earth's atmosphere, is exosphere. This layer lies between 400 and 1000 kilometers. At such greater heights, the density of atoms in the atmosphere is extremely low. Hydrogen and helium gases are predominant in this exosphere. At an altitude of about 500 to 600 kilometers, the density of the atmosphere becomes so low that collisions between the neutral particles become extremely rare. So, this is the structure of the atmosphere. As I said in the beginning of the class, we are covering just the definition of both weather and climate in this class, while making a beginning of our agriculture meteorology part of the first chapter. These definitions are useful. Till our next class starts, please try to understand what is weather and climate by definitions. In the next class, I will elaborate. Weather is defined as a state or condition of the atmosphere at a given place and at a given instant of time, whereas climate is defined as generalized weather or summation of weather conditions over a given region during comparatively longer period. For example, what is meant by weather? The air temperature of our college campus at 2:30 p.m. is 31.5 degrees centigrade. So, particular place, exact number. Climate by definition, in southern India, the winter temperatures ranges from 15 to 30 degrees centigrade. This is average. So, just till our next class, just try to understand these two with small definitions, and in the next class we discuss again on weather and climate, and in that class we try to learn agricultural meteorology, agricultural climatology, scope of agricultural meteorology, possibly very interesting thing, very interesting thing, simple but interesting thing, solstices and equinoxes. Thanking you very much for other students to learn. Just to share this video, subscribe to it. Thanking you very much.